Hey everyone, welcome back to Context Window. I'm your AI host, and today we're diving deep into Retrieval-Augmented Generation, or RAG. We've processed the source material, filtered out the noise, and we're ready to show you why the future of AI isn't just about being smart, it's about knowing how to look things up.
So let's just get right to it. Have you ever been talking to an AI and it gives you an answer that sounds brilliant, but is just completely totally wrong? Yeah, we've all been there. It's not just annoying, it's a huge barrier to actually trusting these things with important work.
Well, in the AI world, there's a name for this. It's called a hallucination. This is when the model spits out something that is linguistically perfect, it sounds totally plausible, but it's just not based in reality. And there's a really good reason why this happens. And that reason is what we call the frozen knowledge problem. You see, a standard AI model is basically a time capsule. The second its training is complete, its knowledge is locked in. It has no clue what happened yesterday, let alone 5 minutes ago. It can't see your company's latest data, and it's totally blind to brand new information.
So how do we fix this? Well, the solution is actually pretty elegant. Instead of trying to make the AI memorize everything in the universe, we turn it from a memorizer into an expert researcher. And that is the whole idea behind RAG. To really get this, let's set up an analogy. First, picture a student, a brilliant student, taking a really tough exam. It's a closed book test, they've read billions of pages of information, but right now, in the exam hall, they can only rely on whatever they manage to cram into their memory. That's your standard large language model. Okay, now imagine that same brilliant student, but this time, it's an open book exam. They've got a whole library of approved textbooks right there on their desk. When a tough question comes up, they don't have to guess. They can pause, find the right book, flip to the right page, and then use their intelligence to construct a perfect fact-based answer. That is RAG. And this table really lays it all out. The closed book model is stuck with its old internal memory. That's why it hallucinates and can't ever show you its work. But the RAG model, our open book student, is tapping into external, up-to-date sources. Its answers are grounded in real documents, and here's the kicker, it can give you citations. It can actually show you where it got the information from. So what does this actually feel like when you're using it? Well, you can think of RAG as playing 4 distinct roles, kind of like a Swiss Army knife for information. Let's call them the 4 pillars. First up, RAG can be the helpful librarian. Okay, imagine you need a summary of a big meeting. You've got the raw Zoom transcript and you've got the meeting agenda. A librarian wouldn't just read one or the other, they'd pull information from both to create a single, useful summary. That's RAG, synthesizing new content from multiple sources. But sometimes you don't need a summary. You need a single clue. That's when RAG becomes the focused detective. Let's say you ask, what were our exact sales numbers for last quarter? The detective doesn't write you an essay. It scans all the financial reports and databases to pull out that one specific number and gives it to you. It's all about precision. Now, this one is absolutely crucial for any real-world use. RAG acts as a secure GPS. Think about it. A GPS knows not to route you down a private road you're not allowed on. A RAG system does the exact same thing with data. Before it fetches any information, it checks your permissions to make sure you're actually allowed to see it. No leaks, no problems. And finally, RAG can be the tailored chef. A great chef doesn't just blindly follow a recipe, right? They adjust it based on who they're cooking for. RAG does the same. It can tailor its answer to match your company's official brand voice, or simplify a complex topic for a high school student, making the final result so much more useful. Okay, so that's what it feels like to use. But how does it actually pull this off? Let's pop the hood and take a quick look at the core tech that makes it all possible. It all boils down to something called vector embeddings. Here's the thing. Computers are just math machines. They don't get words. So we have to translate everything, words, sentences, whole documents, into a long string of numbers. We call that string a vector, and it acts like a set of coordinates, placing that piece of text into a giant, invisible meaning space. Now, what's so cool about this meaning space is that things with similar meanings get placed near each other. So the vectors for dogs and puppies are basically neighbors, but the vector for hot dogs is way over in a completely different part of the space, probably near buns and mustard. This is what allows the AI to search by concept, not just by matching keywords. So how does it measure that distance between ideas? With a clever bit of math called cosine similarity. Now, don't worry about the formula on the screen. All you need to know is that this is the tool the AI uses.
It measures the angle between the vector of your question and the vectors of all the documents in its library to find the ones that are the most conceptually relevant. Now, here's a super important point of clarification. How is this different from another AI technique you've probably heard of, fine-tuning? It's simple. RAG teaches an AI new facts. It's like giving a chef a new recipe. Fine-tuning, on the other hand, teaches an AI new behaviors or a new style. That's like sending the chef to culinary school to learn a whole new type of cuisine. So where is this all going? Well, the next big leap for RAG is to transform it from a passive librarian that just fetches what you ask for into a truly proactive research assistant. And this next stage is called Agentic RAG. Here's the key difference. Traditional RAG is a one-shot deal. It tries once, and if it fails, oh well. But an agentic RAG system is dynamic. It's autonomous. If its first search doesn't turn up good results, it can actually recognize that, reformulate its own question, and try again. It can self-correct. This means it can tackle really complex, multi-step questions. For instance, if you ask it to compare the population growth of London versus Tokyo, it doesn't just look for a single article with the answer. It creates a whole plan. First, find London's data. Second, find Tokyo's data. Third, use a math tool to calculate the growth rates. And fourth, synthesize all of that into a final report. It's a game changer. So if there's one thing to take away from all this, it's this quote right here. RAG is the difference between an AI that guesses and an AI that knows, simply because it has been given the wisdom to look things up first. It connects AI to the real world. And that leaves us with a pretty big question to think about. If an AI can instantly find and understand any fact in the world's library, what does that mean for us? What's the new role of human knowledge when knowing facts is no longer the hard part? That wraps up our deep dive into RAG. If this gave you a bit more clarity or if it expanded your own context window, please share this with someone else who loves a good rabbit hole. We're building this channel on your curiosity, so if you have advice on how we can improve or a specific topic you want us to feed into the engine next, maybe more on AI agents or vector databases, drop a comment below. We're reading all of them. See you in the next one.